Today we're going to look at our first half of section 5.3, which is the double angle formula. The second half has to do with half angle formulas, but today we're going to look at the double formulas. So in order to be successful, we've been working on these for quite a while now, making sure that we are finding the X, the Y, and the R for our radius, making sure we're looking at those quadrants to where we know the correct sign. Then we need to be able to substitute sine, cosine, or tangent into the formula, be able to manipulate the mathematical problem correctly, and being able to make sure that we're picking the correct formula. On your guys' reference sheet, when it's that next little section that has to do with those double angle formulas. So just for example, if you look at cosine, cosine has 3 different formulas. It's just a matter of sort of, in some regards, personal preference on which one you want to pick, and or just with the information that they give us. When it comes to these double angles, you can actually use that sum and difference, well really the sum angle that we were talking about last week, because when it comes to a double angle, if you take 2 of the same angles and add them together, is that the same thing as like a double angle? Yeah. So we'll just do the sine one for the fun of it. So last week we had the sine of alpha plus beta. And we knew that that was, what was it, cosine alpha, sine beta, plus, oh, I'm going to run out of room. I'm going to move this guy. So you guys are always the trial class. Oh, hold on. Mrs. Fitch. Hey. Yeah, that's fine. Yep, no problem. Yep, you're welcome. Bye. Alright, let me where do I do this? I think it's this guy. Make him a little smaller. Alright, I'm going to rewrite that one. Maybe. Alright, so last week when it was like sine of alpha plus beta, we knew that that was cosine alpha sine beta plus cosine beta sine alpha, right? Or whichever order you guys had it in. So when it comes to that double angle, the double angle is saying that you have the same angle, you just want to double it. So for poops and giggles, instead of using alpha and beta, how about we use theta, right? So theta would be in place of alpha, and it's the same angle, so it would be an alpha and an alpha, right? So in our formula, what would we have? Cosine alpha sine alpha plus cosine alpha sine alpha. So if we just wanted to clean it up, we would have the sine of how many alphas? Or sorry, thetas. How many thetas? 2. Theta plus theta is 2 theta. Ooh, somebody got a good sneeze. Can I simplify this at all? Maybe? Yes? No? Are they exactly the same? Yeah, so how many do you have of them? 2. So it would be 2 cosine alpha sine beta, right? And is that what they give us as the formula? Yeah, it's the same thing, right? It doesn't matter which way you multiply something, right? 2 times 3 is the same thing as 3 times 2. So when it comes to the double angles, it's really no different than what we were doing last week when we were doing the sum of the 2 angles. It's just a little bit of a more condensed form, just because your angle that you're looking at is going to be the same, right? And you can do the same thing if you go through the cosine and the tangent. You can get the same exact results out of it. On your guys' sheet and even up here, when it comes to cosine of 2 theta, that double angle for cosine, there's 3 different formulas. See that? And really all it did, like this is kind of like the main one, cosine squared alpha minus sine squared alpha. But what do we know sine squared also equals? 1 minus cosine squared, right? So if you substitute in 1 minus cosine squared and you simplify it, you're going to get 2 cosine squared minus 1, right? What do we know cosine squared equals? What could we substitute? 1 minus sine squared, right? And that's where they're getting this last one. They're substituting in that 1 minus sine squared, and then you get 1 minus 2 sine squareds, right? So all 3 of these end up giving you the same result, but it's kind of like, well, what information did they give us, right? Do we want, if they gave us sine and cosine, we can just pop out that formula. If they only gave us cosine, we can only use that formula. If they give us only sine, then we can only use that one. So it's kind of one of those things, that little personal preference of, do you want to pick and choose which one you want to use, or do you want to do the same one? Does that make sense? Sort of. All right. Want to try a couple examples? So let's say they give us a little picture and they give us a triangle. They can give us triangles. I like triangles. You guys like triangles? You're like, right. Okay, I'll give you a right triangle. And I'm going to say like that angle's my theta that I want to find. Do a little review on all this too. Let's say this side is 5 and this side is 13. So if I want to go through and figure out my double angles for sine, cosine, and tangent, I need to find my sine, cosine, and tangent of this triangle from my angle. So what's missing right now? Yeah, well, that one, yeah. Do we know how to figure out that base, that bottom side? How do we find that out?
5 squared plus x squared equals 13 squared.
Sure, yep, Pythagorean theorem, right? 5 squared plus x squared, whatever variable you want to use, equals 13 squared. So what do we get? 25 plus x squared. 13 squared is?
It's 169.
Yep, 169. What are we going to get? X squared equals 144. X is going to equal 12, right? Technically a positive or negative 12, but since we're talking about the length or a distance, we know it's just going to be the positive 12, right? All right. So then I always go through and I just list out my sine, my cosine, and my tangent, all right? Oops. So sine of alpha. How am I going to figure out the sine of alpha? Up of a triangle.
Would be like y over r. Oh, that's opposite over.
Yep, opposite over hypotenuse. So what's that going to give us?
Oh,
5 over 13. Yep.
I forgot about this formula.
I know. Here we go. I can't remember. Right? What about if I wanted to do cosine of theta? What's cosine of theta going to give me? Yep, which is going to give me 12 over 13. Yep. And then the tangent of theta is going to equal 5 over 12. Right? So now I'm going to throw a monkey wrench in here. I'm going to say that our triangle is in quadrant 2. Is that going to change anything? If I put it in the second quadrant.
Wouldn't, cosine x, so wouldn't that be negative then?
Yeah, yep,
And then wouldn't it bring tangent to be negative too?
yep. So technically my cosine is negative and my tangent is negative. Is my sine gonna stay positive?
Yeah.
Yeah. Yep. All right. So let's go through some of those 3 of the formulas like that they gave us, or some of them, right? So for the first one, let's say we wanted to find sine of 2 theta. So if we look at our fancy dancy little reference sheet, we know that that is 2 sine theta cosine theta. What are you going to put in for the 2? 2. Okay. Times sine theta. What's sine theta?
What?
Sine of theta.
5/13.
5/13. Yep, times 5/13. Times cosine of alpha. And what's cosine of... Sorry, why do I keep saying alpha? Cosine of theta?
-12/13.
-12/13. What do you think you're going to do now? Multiply. If it makes you warm and fuzzy, you can make 2 as 2/1, right? How do you multiply fractions? Straight across. What happens when we multiply straight across? What do we get? Yeah, -120/169. Do you think that reduces?
No.
No. No, so you're good, right? Let's try, how about cosine of 2 theta? A double angle for cosine. When you guys looked at your little formulas on your little reference sheet, out of those cosines, you get to pick 3 of them, right? One of these 3. Anyone in particular stand out to you? You like A, B, or C?
Well, we have both sine and cosine, so.
Stick with A then? I'm good with that. Right? So that would be, what was it? Cosine squared theta minus sine squared of theta. Yeah. So remember back when we were doing those little identities where cosine squared plus sine squared equaled 1? And you guys used to ask, well, is that the same thing? Would it be 1 if it was subtracted? No, it would be cosine of 2 theta. Right? All right, ready to fill them in? What do you want to put in for cosine squared? Yeah. And what are you going to get when you square that?
144/169.
Yep. Right, you can skip that step and go straight to there, right? Minus sine squared, and what are you going to get for sine squared?
25/169.
25/169, yep. Bet you we can simplify that guy down. And what's 114 or 144 minus 25? What was it?
119.
Yep, 119 over 169. Think that reduces? Nah. Right? So we did sine, we did cosine, so we might as well do the tangent, right? It's getting warm out. We all want a tan. I know. I did, it did. So for the double angle of theta for tangent, if we look at our reference sheet, it's going to be 2 tan theta divided by 1 minus tan squared of theta. Right? You guys ready? So I'm going to go ahead and write my 2 as a fraction, just for the fun of it. What was our tangent?
Negative 5 over 12.
Yep. So 2 times negative 5 over 12. Right? All divided by 1 minus tangent squared. What do we want to put in for tangent squared?
25 over 144.
Yep. 25 over 144. Right? And sometimes I go ahead and figure out that fraction first, and then guess what I'm going to change that 1 to? 144 over 144, right? Alright, so now we just got some, we did our plug-in, now we just got to do our chug-in. Okay. So what are we going to get in our numerator? Yep, negative 10 over 12, all divided by 119 over 144, right? Not quite done yet. What do we have to do?
Bring it up top and put it.
Yep, so we have what? Negative 10 over 12 times. There you go. Yep, good job. And then if you wanted to, you could do some cross canceling, right? Or you can just multiply it straight out. You guys want to do this?
Can we just simplify the 10 over 12?
Yeah, you can simplify the 10 over 12. Yep, absolutely. You can do it at any step, wherever you want to do it. Yep. And then what are we going to end up with?
120 or 119?
119. Yep. We are good leaving it like that. Yeah. Elementary school, they always told you couldn't leave an improper fraction. You can leave fractions improperly. Not too shabs? Alright. Let's just start one more example, and we don't have to go through all 3 of them. I think you guys are good with figuring out where to plug them in and kind of just doing like the math or the algebra behind it, right? Little computations. So let's keep working on finding those exact values. But let's say instead of them giving you what sine, cosine, or tangent is, or giving you a triangle and telling you what quadrant it is, what if they gave you cotangent? Would you be good with that? If they said that the cotangent of theta equaled 3, and we'll say that theta lies in quadrant, I don't know, let's go for 3. And they're going to want you to find those exact values of sine, cosine, and tangent, right? Those double angles. So we're going to have to find our sine, our cosine, and our tangent. But they gave us cotangent, right? So now we still got to go back to what we learned last semester when it came to cotangent. And what's cotangent represent? X over y, right? So for us, we have that 3, so that would be like 3 over 1, right? So now we just got to figure out which one, like which one's x, which one's y. Is x and y positive? Is it negative? And all that good stuff. So what do we want our x to be? 3, negative 3?
Negative 3.
Oh, why is it negative 3?
Quadrant 3.
Quadrant 3. So without even thinking about the y, what does y have to be then? It's got to be -1, right? Because a negative over negative is going to give you that positive. Or you can even think of it because of being in quadrant 3, it's going to be negative, right? So then now I can go through with my sine, my cosine, and my tangent, right? What do I need in order to find cosine? I need to find the radius, right? And we know how to find the radius? The radius is going to be that x squared plus y squared, right? You guys good from there? Yeah. So we're going to get r equals square root of 10, right? I would leave it as the square root of 10 for now until you get done with the problem. Because remember how you're multiplying those together? So when you multiply like that sine and that cosine together, that square root of 10 is going to go away for you. Right? So what's cosine theta going to be? Yep. -3 over the square root of 10, right? Whoops, we already did cosine. What's sine going to be? Yep, -1 over the square root of 10. And tangent is going to be? One over 3. Whoops. Yep. Is it going to be positive or negative? Positive, right? Because you get that negative over negative. Yeah, bless you. Right? Then you guys think you're good from there? Yes, no? You want me to do one or are you good? Want me to do sine, cosine, tangent, or you want to do them on your own? Do one? Do it, do it, do it, do it. Which one do you want?
How about we do it and then you do it and then if we
And
see
then-
if we did it right.
Sounds like a good. So which one are we going to do? We're going to do sine, cosine, or tangent? Cosine. So the double angle for cosine. Right.
Yeah.
Don't look at my paper up here. No cheating.